Okay, and so today we are going to look at matrix multiplication. Okay, and so the first thing that we need to be conscious of when we're multiplying matrices or two matrices together is the way in which we do it. So here we multiply row by column, and that kind of multiplication is called dot product multiplication or finding the dot product, and it's not something we need to worry about, but it is a little bit different kind of multiplication than we've had before. So say, for example, I have a matrix here, 1, 2, 3, 4, and I have, that's A, and we have B is equal to, we'll say 5, 6, 7, 8. So we're going to multiply those two matrices together. And so basically then, when we're multiplying those two matrices together, we would go row by column, and that will give me the first element of the new matrix. So we're going to have a look in the next slide on how to do that further. So as we said, we multiply row by column. So here, well, in the first, we have this row multiplied by this column. That's going to give me the first position. So here I will have 1 is going to be multiplied by its corresponding element, so by 5. And then we're going to add, well, the second element of that first row is 2, and that's going to be multiplied by the second element of that second column, which is 7. Here, so that's the first. So correspondingly, I'm going to have the first row by the second column. So here I'm going to be doing the exact same, but to fill this spot here in the matrix, so I'll have row by column. So here I'm going to say that is 1 multiplied by, this time it's by 6, plus, and here again we have 2, and this time it's multiplied by 8. Okay. The next one then I'm going to have 3, and it's going to be multiplied by, well, again I go here, row by column. So 3 is going to be multiplied by 5, plus here the second element of this row is 4, and it's going to be multiplied by the second element of that column, which is 7. Okay, so maybe pause the video now and see if you can work out what the multiplication here would be. Okay, so if you've given it a try, let's see what it would be. So it would be, well, the bottom row, so that's 3, by the second column in the second one, so 3 by 6, plus, and here we have, well, again, the bottom row in the first matrix is 4, by the second column is 8. And just interestingly, before we tidy both of those up, here I can see the 5s correspond there, don't they, and the 7s here, the 6s and the 8s, but also my black ones here correspond, 3 and 4, and here 3 and 4 are 4 and 4 as well. Here my 1 and 1 and my 2 and 2. So you can see how, but here the vertical elements correspond to the vertical elements, and then here on each horizontal, the horizontal ones correspond. Okay, so now we are just left to tidy it up. So here I have AB is equal to, so AB is equal to, well, 1 by 5 is 5, plus 2 by 7, well, that's 14. 3 by 5 is 15, plus 4 by 7, well, that's 28. Over here, 1 by 6 is 6, and 2 by 8, well, that's 16. And here, 3 by 6 is 18, plus 4 by 8, well, that's 32. And we just close off our matrix. And so, just to tidy it up then, we have AB is equal to, well, 5 plus 14, that's 19. 6 plus 16 is 22. 15 and 28, well, that's 43. And 18 plus 32, that's 50. Okay, and just we'll put a red box around our answer. Okay. Now, so that's basically our matrix multiplication, and the important thing that we would always remember when we're multiplying two matrices is it's or C. So I used to remember it as Roman Catholic, but anyway, or C, so that's for row by column. Okay, we'll just do one more. Okay, so here we're given another two matrices, this time C, and we can C and D. And here we're asked, can we find CD? Now, if I was to just move this down here, if I am to look at the dimensions of this one, well, I can see how many rows are in this. So it's a 3 by 2 columns times matrix. And here I have another matrix, and this time it's a 2 by 4 matrix. Now, if I wanted to find C plus D, I'd know that I can't do that. Why can't I do it? Because the order of the two matrices is not the same, if we remember that. So we remember that as their order or their dimensions are not the same. That doesn't apply to us when it comes to matrix multiplication. What's important when it comes to matrix multiplication is that the two dimensions nearest to each other, that these two are the same. So if I'm multiplying these two matrices, then this figure, the column in matrix 1 and the row, the dimensions of it in matrix 2, they must be the same. And what's interesting is they're going to give us a matrix that turns out to be of the order or to have dimensions 3 by 4. So we're going to see that now in a moment when we multiply C and D together. So here, well, I know I'm going to start off with row by column. So my first row is 1, and it's going to be plus 3 here. And the column that it corresponds to is the first column. So 1 is multiplied by 2, and 3 is multiplied by 3. For my next bit of multiplication, I'm going to have, well, the next row, again by that first column. Okay, so here I'm going to have 5, I'm going to have my plus sign, and I'm going to have minus 2, and they're multiplied again by that first column, so by 2 and by 3. And then my last one then in this column is going to be of minus 4, and it's also 0 is in that same row. And then that first column here in the second matrix, in the D matrix, is going to be 2 and 3. So that's the first part done. So we're going to see this is going to take us much longer. So now I'm going to be doing each row again by this column. So it'll be 1 by 3 by this, and that also by that. So again, pause the video and see if you can get the next bit, or maybe see actually if you can get it all completed, and I'm just going to work away. So here I have my 1 and 3, my 5 and minus 2, my minus 4 and 0. So I have each row written out, and now I just need to multiply them by the second column. So minus 1 and 7. Here again, minus 1 and 7. And here, minus 1 and 7. So that's the next one done. Okay. Similarly again now, I've just written out each row again, and so I need to multiply those. So again here it's each row, and this time we're on to the third column, and this row and the third column, and this row and the third column. So here I'll have 1, well, that's going to also be multiplied by 1, plus 3, well, that's going to be multiplied this time by minus 2. Here I'm going to have 5, that's times 1, so the first element of that third column. And here the second element of that third column is minus 2, and here 1 again by minus 2. And so we're on to the last one. So this time again, it's row by column. So 1 and 3 times 3, 0, and 5 and minus 2 times 3, 0, and minus 4 and 0 times 3, 0. And so I'm going to have 3 here and 0 here, and again 3 here and 0 here, and likewise 3 there and 0 here. And so then I'm just going to close my matrix and tidy that up. Okay, so and just to tidy it up then, I'm going to say, well, CD is equal to, well, 1 by 2 is 2, plus 3 by 3 is 9, 5 by 2, well, that's 10, plus by minus is a minus, and 2 by 3 is 6. Minus 4 by 2, that's minus 8, and plus 0 by 3, well, anything multiplied by 0 is 0. Then, likewise, in my next column, I'm going to have 1 by 1, positive by negative is negative, plus 3 by 7 is 21, 5 by minus 1 is minus 5, plus by a minus is a minus, and that's minus 14, and minus 4 by minus 1, well, negative by negative is positive, and that's going to be 4, plus, well, 0 by 7 is 0. And here then my next column, I have 1 by 1 is 1, plus by a minus is a minus, and 3 by 2 is 6. And here again we have 5, plus minus by minus is a positive, so again it's going to be positive, and 2 by 2 is 4. And here minus 4 plus 0 by minus 2 is 0. Next then we have 3 plus 0. 5 by 3 is 15. Plus by a minus is minus, but it's 0 anyway. And minus 4 by 3 is minus 12 plus 0. And again, I'm just going to close the matrix and just tidy it up then. So just to tidy it up, 2 plus 9, well, that's 11. 10 minus 6 is 4 and minus 8. Minus 1 plus 21, well, that's 20. Minus 5 minus 14 is minus 19, and 4 plus 0 is 4. 1 minus 6, well, that's minus 5. 5 plus 4 is 9, and minus 4 plus 0 is minus 4. And then in my last column, I have 3, I have 15, and I have minus 12. I close my matrix, and that's my answer. So I'll put a box around it. But again, we can see, if we just look, well, what dimensions do we have? Here we have how many rows? Well, 1, 2, 3 rows. 3 rows by 1, 2, 3, 4 columns. So exactly as we had predicted before, that we would have a 3 by 4 matrix as our solution. Okay. So just there, the last couple of things to remember with matrix multiplication. One, that that it's always that we multiply row by column. Exactly as we said, for matrix multiplication, it's always row by column, or C. And then the other last bit that we'd said, well, in order to multiply two matrices, if their dimensions are A by B and C by D, then we can only multiply them if and only if B is equal to C. So these two have to be the same, and then the matrix at the end, the resultant, so if that was A and this was B, then AB can only be multiplied together if these two are the same. But AB at the end will look like, it will be A times D. That will be its dimensions. Okay? Now, so as a learning check, so we're going to go back for our learning check. We're going to go back to the first example that you've taken down. And here the question is, if A equals 1, 2, 3, 4 and B equals 5, 6, 7, 8, this time I want you to find BA, because we're going to learn something very interesting in this learning check. We're going to see, does order matter in terms of, is it commutative in matrix multiplication? So we know from normal multiplication that we've done before that 2 by 3 is the same as 3 by 2, because they both give us 6. But here we're going to see, well, does that happen? Is that true for matrix multiplication too? So take that first example that we did, and for your learning check, do BA. And then you'll be able to submit an answer on Schoology for that.